Okay, sorry. I just got cut off there for a second by my phone. So we finished these questions. There's some homework questions here from the textbook. You can either take a break now and work on these questions before moving on to the rest of the note, or you can finish through the second page of the notes and do all the practice questions together. So I'm just going to keep going. If you want to pause and work on practice for a while, then that is up to you, whatever you choose. So the next and last bit for today is talking about dilutions. So the last note about concentration that we just finished was all about how to make a solution based on weighing out a specific amount of a solute and putting it in the solution. But you can also prepare a solution from an existing solution by changing the concentration by either adjusting the amount of water that there is. So this is called dilution. For example, if you have concentrated orange juice in a can, you would put that into another container and you would add 2 or 3 cans of water to dilute the concentrate so that it's the right concentration for drinking your orange juice. Works the same way in chemistry. So if we have one solution, let's say, we'll draw a container here, and let's say that it has 12 moles of some substance. So I'm going to draw 12 dots. 1, 2, 3, 4, 6, 7, 8, 9, 10, 11, 12. So 12 dots. This is going to be our solution 1. And it has a specific volume and concentration, and it has a certain amount of moles dissolved in it. If I add water to it, I now have a new solution that has a different volume and a different concentration, but there's still only 12 dots. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So still 12 dots. The dots represent the moles. So there's the same amount of moles in each solution, but the volume is different and the concentration is different. So let's make a note of that. When you dilute something, it has the same amount of moles, but different volume and concentration. Volume and concentration. There we go. So in beaker 1, we have a certain amount of moles equals concentration times volume. So remember our C equals N over V, or that magic triangle N is C times V. And solution number 2, again, has the same concentration, N equals C times V. So if the number of moles is the same in both of these, then it would then mean that if you have the concentration times the volume, would be equal to the concentration times the volume of the other one. So let's see what this looks like in an example of a question. A solution of sulfuric acid has a concentration of 2 moles per liter. What volume would be needed in order to make a 100 milliliter solution of sulfuric acid having a concentration of 0.10 moles per liter? What people find the most difficult about these types of questions is figuring out what's C1 and what's V1 versus what's C2 and what's V2. What is it you're looking for? People sometimes get them mixed up, and that's how you end up with the wrong answer. So in this case, concentration number 1 is 2.0 moles per liter. So there's concentration number 1. And it says what volume of this would be needed to make a different solution. So we're looking for V1. That's what we don't know. The solution that we're making has a volume of 100 milliliters and a concentration of 0.1 moles per liter. So C2 is 0.10 moles per liter, and V2 is 100 milliliters. When you're working with this equation, if you're given milliliters, you can use milliliters. You don't have to convert it into liters, only when you're using this C1 V1 equals C2 V2. So C1 V1 equals C2 V2. We're looking for V1, so we isolate that. V1 will be equal to C2V2 divided by C1, so we move that over there by division. We can sub in all of our numbers. C2 is 0.10 moles per liter times 100 milliliters, divided by C1, 2.0 moles per liter. Moles per liter, oh, sorry, didn't mean to cross the whole thing out. 0.1 moles per liter, there we go. Moles per liter divided by moles per liter will cancel it. We'll be left with a unit of milliliters. 0.1 times 100 divided by 2 is going to give me 5.0. We need two significant figures here. So therefore, you would need 5 milliliters. Oh, actually, we only have one significant figure here because there's no decimal place. So we'll get rid of that. We only get one sig fig. So we're going to round that to 5 milliliters of the concentrated solution. So we would need 5 milliliters of this 2 moles per liter solution in 100 milliliters to make our solution with that concentration. Let's do one more. What is the molarity, so this time we're going to be looking for one of the C's, of a solution prepared by diluting 55 milliliters of a 1.25 moles per liter solution of cobalt chloride to 100 milliliters? So concentration of the first one, C1, is 1.25 moles per liter. 1.25 moles per liter. And we have 55 milliliters of it. So V1 is 55.0 milliliters. C1 is what we don't know, or sorry, C2. C2 we're going to find. We're finding the molarity. If we change this solution so that it has a volume of 100.0 milliliters. So again, C1 V1 equals C2 V2. This time we're solving for C2. So C2 equals C1 V1 divided by V2. We can sub all of our numbers in. C1 is 1.25 moles per liter times 55.0 milliliters divided by 100.0 milliliters equals milliliters divided by milliliters. When you have two volumes, if one of them is in liters and one of them is in milliliters, you have to convert them, one of them, so that they're the same. They can both be in milliliters or both be in liters, but they have to be the same unit so that you can cancel them out and be left with a concentration number, because that's what we're trying to find, is concentration. So we sub all these numbers into our calculator. We're left with moles per liter as our unit, 0.6875 moles per liter. We have 3 sig figs here, 3 sig figs there, 4 there. So our final answer gets 3 significant figures, which equals 0.688 moles per liter. Therefore, the concentration would be, so this is of the new solution, would be 0.688 moles per liter. We're going to do some dilutions in class, so you'll get to see that in action. Homework questions are on the back here. Don't miss them. There's a few from your textbook. I've left this blank page so that you can do your homework on there. So there's total homework questions, if you didn't already do the set from the first one, is 4 questions on concentration, moles, and volume, and then 4 questions on dilutions. And this will help you get ready for when we do the lab of making a solution and then diluting it to make diluted solutions. You'll also have the instructions here for how to prepare a solution. We'll go over this in class when we do the lab, but if you want to take a read through it, that wouldn't hurt. And that's it. So please make sure you finish the homework questions. If you haven't already finished the solubility curve Excel activity and handed it in, make sure you get that done because I'll be collecting it next class. Have a great day.